Let's take a look at this problem here, question 13.18b. You can see we're going from the same starting material that was in 13.18a, but we're making this new molecule here. And hopefully you can see right off the bat that you can see that this piece of the molecule here appears twice in this molecule, twice over here. So the way we can make this kind of molecule is by converting our starting material into a Grignard reagent and by treating this with an ester. Because you remember that a Grignard reagent can add 2 times, and so we have 1, 1, so 1 plus 1 equals 2. So if we use 2 Grignard reagents, so if we convert this into, use 2 equivalents of Grignard reagent, we should be able to make this from an ester. So we need to figure out what piece of an ester we need to do this. So let's take a look. How are we going to do this? So the first thing we're going to have to do is we need to protect that hydroxyl group. So we're going to use trimethyl chloride and triethylamine are same conditions, and we're going to generate the same thing as we did in 13.1a. We're going to generate our OTMS, or our silyl ether, and then we're going to put our bromo over here, won't forget it this time. Then we're going to treat this with magnesium and diethyl ether, or THF, and we are going to get a Grignard reagent, OTMS, RMG, and there's our halogen. So now we have our green, so this is our Grignard reagent. You've made a Grignard reagent. You can say it's a protected Grignard reagent, so a very fancy type of Grignard reagent. So what we need to do now is we're going to treat that with an ester. We're going to add that to an ester. So what we're going to do is we're going to use 2.0 equivalents of this, and we're going to add it to this ester because this is the piece we're going to require. And it's going to add to this 2 times. So we're going to add, I'll just put 1 equivalent of this here, and then we're going to need to quench that with water or as a proton source. So what we're going to end up with is we will have this with our TMS, oops, I'll erase that, with our O trimethyl, I'll draw it out here on this one, OTMS, and then we're going to have, that's going to have attacked this ester and added twice. You might want to practice drawing out this mechanism for fun. And then over here we have OTMS. And then, just to make this video short and sweet, excuse me, we're going to treat this whole thing with TBAF, and we will end up with our final product. We'll end up with the final product. So we're going to remove, we're going to cut this silicon bond, and we're going to cut the silicon bond on this silyl ether as well. And remember what I said, that the silicon fluorine bond is really the driving force behind deprotection, because when you treat this, when you treat the silyl ether with TBAF, those fluoride ions are all around the solution, and what they do is they will act as a nucleophile and they will react with the silicon. They form a really strong bond, and then you regenerate your alcohol. So after you do that, you will end up with your product, which is right here. So this is your product. So I would want to be able to recognize when I need to use a ketone or an aldehyde or an ester in a Grignard reaction, and this time you need to use an ester. So this is the ester we would use.